Today I'm going to present the insurance recommender system, which is my research topic, continuing from last semester. Um, I have introduced from last semester, I will introduce the recommender system, say what it is, what technologies can be used for recommender system, and what can be used for my methods, my research first. First, the recommender system, it's a selection guidance system like I introduced in last semester. It's used in many platforms and social networks like Amazon, Netflix, YouTube. It helps to leave the customer on their website longer and give them a better user experience and a lot of choices. Um, so it helps the shoppers as well as the sellers. There are some technology that listed used to be below, like content-based, collaborative filtering, knowledge-based, demographic-based, utility-based, and hybrid systems. These are all used recently in technology in platforms, and these technologies can all be used for recommender system. Since we introduced them last semester, I would not reintroduce them here. You can see from the slides follows, and it has all been saying which the technology is and where it can be used. For for my research, I will use the hybrid model. The hybrid model is researched by many um, researchers, and it has shown good predictive power as well. It's very clear for researchers and learners to see what is being predicted and what it's used to predict. It's very clear the demonstration power of the um, hybrid model is very good. For insurance product, we can see the user have an item have a matrix. The matrix factorization can be used here to see how likely a user will choose a product. For um, multi-dimensional approach, we can see from above the rating is introduced can be produced by a user um, importance matrix times a characteristic matrix. This produces a rating, the basic rating for a movie from a user. We can see from the example here, the user will give their um, importance rating for each factor, and a movie will have a product, an insurance product will have their feature ratings, and when you times them together, it gives a score a user can give for a specific policy. Um, After introducing the algorithms, we'll go into details about how we select our data and do our modeling. And the data selection criteria, as I listed here, I evaluate the data based on the 6 core dimensions of data quality here. After evaluation, I choose Allstate insurance purchase history as my data set, and evaluate them based on these core. After data evaluation, we'll first do data exploration. In this step, we'll learn about the data and which and how we can use the data, how to learn about the data features and how we can use them in our modeling. As we can see, there are some missing value, there are some NA values, and we will keep that in mind when we're trying to fix them. Here, the data exploration, further we can see what their categories are, what each value of the variable, and their distributions on the left. It give us the idea of how the data can be used and what's their pattern. and it's after visualization, uh, it gives us better idea of how the data is distributed and how we can use them. Um, I found two kind of interesting patterns. One is the dependent variable, which we want to predict. They are somehow correlated. The A through G, um, we will know the some of them are correlated and keep them in mind when we're making our prediction. Um, and there's another one. It's a shopping point and the uh, purchasing point, which is the last purchasing point have a very good predictability of the final insurance product the user will choose. This is a kind of pattern that we discover from data exploration, and we can exploit it in our data modeling process. um, our data pre-processing step is trying to fix the incomplete data and null data we found in our data exploration step, and making our data ready um, for our modeling. Like in this step, we can do some simple clustering and modeling and trying to fill in missing value with predictions. After doing the processing and getting rid of correlation and collinearity, we are good to go into our um, experimentation. In the experimentation step, we're going to use different model to fit our data and try to predict what the final insurance product the user will purchase. In this step, I used a rule-based model, tree-based model, neural networks, and generalized linear model to make our prediction. The generalized linear model, it's actually the hybrid utility model which I studied. It's a special case of the generalized linear model and you really have good prediction power, and it's very demonstratable about which variable is used and how it affects the prediction. As we can see, since I can upload the result onto the Kaggle website, I can compare the result and see if they are accurate. I first upload the rule-based model, which is the um, last shopping point baseline prediction, and it has a very high score for our prediction. You can see from the the results here. Um, Second, we will use the generalized linear model, which is a hybrid utility model we introduced. It's a generalized version of the hybrid utility model. It has a very good prediction power. It's as high as the rule-based model shown before. Um, it has a good prediction accuracy, so we'll keep that in as a choice to choose from. And then we use the tree-based model, exposed another random forest models. It has a better prediction power than the baseline model and generalized linear model, since it's a very um, complex technology that's used both combine the linear and non-linear cases and use tree development for the prediction. um, as we can see, as a conclusion, we can see the recommender system, the hybrid utility model, is in line. Its prediction accuracy is in line with either rule-based model or tree-based model. It's very good predictable. It has very good predictive power. Um, even though it's not the highest, but it's already very high. It's within 1%, 2% accuracy of all the highest model. Um, so the Actually, the studied hybrid utility model, which is a special case of the generalized linear model, it's a very good predictive predictive facility. Um, it can help us to learn about modeling and learn about how the user would choose the insurance product. Even though there are some spaces still to improve, it's a very good model we can use. The references of my research is listed below. If you have any questions, please let me know. Thank you. The references of my research is listed below. If you have any questions, please let me know. Thank you.